Welcome to Discovering. Fish stocking plays an important role in the ecosystem of the Great Lakes. How, when, and where to do it is driven in great part by information obtained through tagged fish. So just how do you tag all of the millions of fish that are stocked in the Great Lakes? We'll find out tonight right here on Discovering.
The secret streams that flow beneath the cliffs of colored stone. Forests thick and healthy with birch and pine and oak. Surrounded by the greatest lakes this world has ever known. The black bear's awesome presence as he roams the hills and fields. Call of the timber wolf, the loon's lonesome trill. The eagle soaring high above, the trout lies deep and still. These are what I treasure, the only way I measure feelings that I have for this fine land. There is so much to discover when you're a long-time lover of northern Michigan.
There are multiple reasons for stocking fish in the Great Lakes: to restore native fish populations, control invasive fishes, or to diversify our sport fishing opportunities. Information obtained from tagged fish plays an important role in determining how stocking operations are carried out as well as the level of their success. The Great Lakes Fish Mass Marking Program began back in 2005. Its goal? To tag every fish stocked in the Great Lakes. To find out how and why, I visited the Marquette Fish Hatchery, where I met with Chuck Bronte, Senior Biologist at the Green Bay Fish and Wildlife Conservation Office of the U.S. Fish and Wildlife Service, as well as Director of the Great Lakes Fish Tag and Recovery Lab.
It's called mass marking because the intent is to actually tag and fin clip every salmon and trout that gets stocked in the Great Lakes. The genesis for the idea came from the Council of Lake Committees of the Great Lakes Fishery Commission. They wanted to see a mass marking program brought to the Great Lakes, modeled after the one in the Pacific Northwest, which is used to manage salmon fisheries there. So back in about 2005, they tasked a group of state, tribal, and federal biologists to actually look at mass marking technology used worldwide. We did that, and we decided that using coated wire tags and the adipose fin clip would be the tool of choice. Given that that decision was made and then adopted by the CLC, the state agencies actually went up to Capitol Hill and got us some money to buy some of these trailers. This trailer here was one of the trailers purchased with some of that money, which was earmarked by Congress, but also funding provided by the President Obama's Great Lakes Restoration Initiative, which is managed by EPA. And that money from EPA and through the initiative has funded the program since 2011 till the present day.
Okay, the idea of the program of the auto clipping trailer is the auto clipping trailer will identify the adipose fin on a fish. The adipose fin is a short, fleshy fin below the dorsal fin. The 3-inch fish will go through the trailer and it'll clamp the fish down and identify this fin with a dotted line, and the clippers will come down and remove the fin off the fish. Simultaneously, it'll insert a 1.1 millimeter tag into the snout of the fish, and this stainless steel tag will remain in the fish throughout its life. And should a fisherman catch this fish several years later, he will identify this fish as carrying a tag by the missing adipose fin. And then the head portion of the fish is cut off and sent into Fish and Wildlife Service or the Michigan DNR office, and then the tag is extracted and the random code is read off the tag. The random code on the tag indicates what hatchery it was stocked at, what location it was stocked at, and then it goes back, fed into the computer, and we can get total number of fish caught, what location this fish was caught at, where it was released. Infinite amount of information related to this random code on this tag.
The primary objectives of the program are to be able to look at the performance of hatchery fish across hatcheries, strains, jurisdictions, looking at which fish are contributing the most to both sport, commercial, and treaty fisheries, and also measure levels of natural reproduction of salmon and trout. And this is important so that we make sure that we're not stocking too many fish into the Great Lakes that can't be supported by the prey base that's available. The lakes are now producing wild fish in quite high levels, especially Chinook salmon in Lakes Michigan and Huron.
Yep, that's a planter fish, missing an adipose fin.
For the lake trout restoration program, we look at measures of natural reproduction as our benchmark on the success of the restoration program. Hopefully we'll get to a point where the lake will be producing more fish than we're stocking, and we can cease the stocking program for lake trout. The states are interested mostly in managing their multi-billion-dollar salmon fishery, which is centered around Chinook, coho, and steelhead trout. To date, we've tagged over 60 million lake trout and Chinook salmon, stocked mostly in Lakes Michigan and Huron. There's a similar program going on in Lake Ontario that's carried out by the cooperative arrangement with the state of New York and the Ontario Ministry of Natural Resources.
To start out the process, we get the fish from the hatchery, we bring them into the trailer by bucket or pump, whatever is set up at that hatchery. Lake trout we have to manually put up into the sorter because they get stressed a little more and don't run as well through this fish pump. So with salmon, there's actually a valve down in here that moves up and down that lets the fish through, and they come through this pump down below here. So the salmon will get pumped up through this tube, and they go up into the sorter. So we actually don't need an individual manually putting them in there. These trailers were designed in the Pacific Northwest specifically for salmon. So because of that reason, they react and go through the pump well. Lake trout, it wasn't designed for lake trout really. The company NMT has made modifications so that we are able to run lake trout through here, but we have to do it manually because they get too stressed and they don't run through the machines very well then. They come into the trough, and then here is Aaron. He's sorting the fish, putting the fish up into the sorter, which is this mechanism up here. There are pumps. We can pump the fish into the trough. We can set up a pump out in the hatchery and pump them up through the little door right there. But that adds more stress to the fish. And we found that, bringing them in by bucket is definitely less stress on the fish, and they seem to run better through the lines more efficiently. So Aaron is putting the fish in here. There's two channels coming down here, and this is a big camera, and this camera measures the fish to the nearest tenth of a millimeter. And you can actually see this on this screen. It shows the two channels measuring each fish to the nearest tenth of a millimeter, and it sorts them by size. Now there's 6 lines. That's what's out on the floor out there. 6 individual lines with specific sizes, so it sorts each fish by size. Once they get sorted, they get put into a VE out there, and then they individually will come through the channel. Once they come through these channels, they come down to the Mark IV, and there's a sensor in here that triggers a clamp to to hold the fish. It briefly holds the fish. This mechanism moving up and down actually clips the adipose fin on this fish. So it clips the adipose fin. That will tell the agencies and anglers when they catch a fish, if that fin is missing, only the adipose fin is missing, that means there's a coat of wire tag in the snout of the fish. As that mechanism is moving up and down and clipping, there's a needle with wire inside this Mark IV that injects a tag into the snout. These are the moving parts that actually, they're the clamps that hold the fish. So those are specific to the size. And they're also, there's salmon setup, and then there's a lake trout setup as well. So that's a difference as well. And then there's a head mold where the fish's nose comes into. These have different sizes, and also they're specific to species as well. So there's lake trout ones, and then there's salmon ones as well. So this is a spool of wire, and there's just a guide here that it goes through a little tube. And these green things are the drive rollers, and the wire goes between them, and they push the wire through. And there's a needle in here, and this is called the cutter, and it cuts a 1 millimeter length tag, and that injects it into the snout. After it clips and tags it, it drops the fish through this blue tube, which is the QCD, the quality control device. Now with the camera here, there's a camera also, that's how it picks up the fin. The camera detects whether it clipped the fin or not, and then when it goes through the QCD, it detects whether there's a tag present or not. If it is successfully tagged and clipped, it'll send it out to the back pipe here on the wall, which is going out of the trailer into the raceways. If it's missing a tag or clip, it goes into the reject bucket. And from there, that's what the two people in the back are doing, is they come by and give it a tag or clip, whatever it's missing, so that they successfully go out. So these are the fish that are rejects from the lines, or fish that are too big or too small to go to the lines. What Terry and Nancy are doing back here is tagging and clipping them manually, clipping the fin with the scissors, and then they tag the fish here, basically just taking the fish, and they drop it through. This is another QCD, and it detects whether it has a tag, and if it does, it sends it out to the raceway. Back here with a team of two, generally they can do 5 to 1,000 fish per hour, so they're experienced and they're very good at it as well. The actual tag is on the tip of this, and on this, laser etched, there is a 6-digit code laser etched on the wire. So the 6-digit code then tells us what species of fish, what strain, the year class of the fish, and where it is stocked. And then when the fish is recovered, we can get all that information once we recover the tag and read it under the MagnaViewer. And then that's how we compound all the information too, is we get all that back to the states and the agencies cooperating with us. Everything is touchscreen here, touchscreen computers, but these operate the lines, and this tells us the success rate going through the line. So this one, for instance, is 97% have been tagged and clipped, 3% are going to the reject bucket. Overall, we're running about 88% right now, which is a little bit low. Generally, we run 95% or a little bit higher. We take a quality control every 2 hours out of the back of the trailer to measure what the success rate is. And when they go into the raceways, usually it's about 98, 99, pushing 100% is what they are. They do lose tags over time a little bit. So by the time they get stocked out, usually they are in the 95 5% range when they go stocked out. That's about average. And then these screens up here are the 6 lines showing the clipping mechanism in live action. That's so it can help us monitor what's actually going on, making sure that the fish are being held correctly and getting popped up so that the adipose fin gets clipped. So when you see the fish come in, you can see the fin, and then it actually clips it and it's gone. These also then tell us how many fish we've done at the end of the day successfully. So it's an accurate number going out of the trailer so that we know how many are going in each raceway. So with the trailer, now we're doing fish averaging 7,500 per hour, as high as 10,000 per hour. So we're able to go through fish a lot quicker than the old method. They used to just tag them by hand. It used to take, at the federal hatcheries, when we have 1 to 2 million fish, it would take them months with a crew of 6 people to tag and clip all those fish. Now with the trailer here and the technology, we're able to do that in less than a month, depending on how many fish we have there.
Most people would be amazed at the technology that's being used inside this trailer, but really the important part of the program is the data recovery effort. And for that, we have hired between 11 and 13 technicians stationed around the Great Lakes, working in cooperation with state management agencies, interfacing with anglers at tournaments, fish cleaning stations, and boat ramps to actually look at their catches in order to recover tagged fish and collect biological data on them, but also looking at collecting information on their wild counterparts. And we can tell a wild fish from a hatchery fish by the fact that the wild fish doesn't have a fin clip or a coated wire tag. Like I said, we have 4 of these marking trailers. Currently, actually to date, we've tagged over 60 million trout and salmon. This trailer here is marking about 210,000 lake trout for the state of Michigan that will be stocked into Lakes Huron and Michigan as part of the consent decree agreement with the tribes. From basically August through the end of September, these trailers will visit 5 of our federal fish hatcheries in Michigan, Wisconsin, Pennsylvania, and Vermont, and we'll be tagging an additional 6 million lake trout raised by the Fish and Wildlife Service to be stocked into Lakes Michigan, Huron, Erie, and Ontario. The Fish and Wildlife Service does not do this unilaterally. This is done in partnership with the states and tribes around the Great Lakes that have management authority over the fisheries. The Fish and Wildlife Service per se does not have any management authority, but our office is in the job of providing technical assistance, technical management assistance to the states and tribes. And with this program, we're providing a high level of scientific support to the states and tribes in managing these fisheries. We couldn't do it without them, and we certainly would not do it unilaterally without their consent. And we're happy that they invited us to the party, so to speak, to implement this program with them and help them with their management efforts. Right now, about 70% of all the Chinook salmon caught in Lake Michigan are lake produced. They are not from hatcheries. And without the mass marking program, that type of information would have not been available. And it's important that the states have that information so they can make the right decisions on the number of fish to stock in Lakes Michigan and Huron. As far as the lake trout program goes, most of the tagging centers around evaluating the performance of several genetic strains of lake trout that we're stocking into Lakes Michigan and Huron. Basically, we're looking at the differential survival over time by marking specific lots of fish of different genetic strains. For both species, we've documented movement of fish throughout Lakes Michigan and Huron. Specifically Chinook salmon, one of the more interesting results there, and not surprising given the biology of the animal, is that during the summer open water season, let's say in the state of Wisconsin, probably only about 30% of the fish caught by anglers fishing in Wisconsin were actually stocked by the state of Wisconsin. That is to say that fish from all jurisdictions on Lake Michigan are contributing to that fishery, and even fish coming from Lake Huron. There has been a documented movement of stocked fish from Lake Huron for several years now, and that seems to coincide with the collapse of the Alwye Forge base in Lake Huron. But they are contributing to the populations in Lake Michigan, as well as wild recruits coming from Lake Huron and coming from within Lake Michigan. So knowing the total predator population and its composition is certainly an important component to managing these valuable fisheries. With lake trout, the movement information is a little bit different. They're basically stay closer to where they were stocked. But even though we stock a lot of fish on the historically important offshore reefs, a lot of those fish are leaving the reef area or the refuge area that they're stocked in, and are contributing to nearshore fisheries within about 100 to 150 miles of where they were stocked. So even though they're planted offshore, a significant portion of the population are available to anglers.
Well, that's it for tonight. If you'd like to keep tabs on what's coming up on Discovering or see where we've been, you can join us on Facebook or go to 906outdoors.com. Thanks for watching, and we'll see you next week right here on Discovering.